Today we're going to start quadratic equations lecture number 1. This is an important chapter for class 10 and class 11 and JE also. So we will start from very basic of this chapter and we will go to advanced. Okay. So let's start. Today we're going to cover these topics: introduction to quadratic equations, ways to solve quadratic equations, and discriminant. Okay. Or you can say nature of roots. The last topic is nature of roots also, you can say that. So let's start. Before starting the chapter, you should know some terms. What are those terms? First term is equations. Okay. Second term is inequations. Third term is what? Third term is expression. And fourth term is identity. You should know these all terms to make your journey smooth in quadratic equations. Okay, so I am explaining this. So if I ask you what are equations, that is simple. You can write equations like x squared plus 4x plus 1 equal to 0. Okay, or you can write x cubed plus 3x squared plus 3x plus 2 equal to 0. These equations are valid for some definite values of x. Okay, not any values of x, for some definite values of x, right? And when we talked about equations, let's talk about identity, which are opposite of equations. Okay, then we will talk about these two topics. What are identities? Let us write an identity, then you will know easily what are identity. Let us write x plus y whole square equal to x square plus 2xy plus y square. Now, this is an identity because this is valid for any values of x and y, for any value of x and y. Okay, if you put x equal to 1, y equal to 100, this will also be valid. Okay, if you put x equal to y equal to minus 3, this will be valid. So, this is valid for any values of x and y. And you can also write an identity, trigonometric identity, sine square x plus cos square x equal to 1. This is always valid for any value of x. So this is also what? This is also an identity. Okay. Now let us talk about these two. First we will talk about inequations. If we remove the equal sign from equations and put greater than or greater than equal to or less than equal to or less than or not equal to sign, then that will be a inequation. Simple. Okay. So if we write this as an inequation, this will be x squared plus 4x plus 1. Let us take this is greater than 0, or this is greater than equal to 0, or this is less than 0, less than equal to 0, or not equal to 0. These all are inequations. Okay. So I hope you understood about inequations. Now let us go for expressions. What are expressions now? Now, if we remove equal to 0 part from equations or greater than equal to 0, less than equal to 0, not equal to 0 part from inequations, what we will get? This part will be left here, right? Right, x squared plus 4x plus 1 This what will only be left here. So this will be an expression. Okay, this is not equation, not in equation, not any identity. This is simply an expression. Okay, or you can write, if we write this as an expression, this will be x cubed plus 3x squared plus 3x plus 2. This is an expression. Okay, so I hope this will clear your concepts about these all four terms. Do not be confused in any terms. Okay, so now let's start our main topic, quadratic equations. Now, if I ask you what is a quadratic equation, what you will say in simple language, what you will say? You will say maybe that the equation whose highest power is 2. Yeah, that's correct. Okay, that's correct definition. So, if there is an equation like x squared plus 2x plus 3 equal to 0, this is a quadratic equation because the highest power is 2 here. If we remove if we remove this equal to 0 here, what it will be? This will be a quadratic expression, right? Now, this can be said as quadratic polynomial also. Okay, whose degree is 2? Whose degree is 2? So we can write this as this is equal to fx, function of x. Okay, so this will become a quadratic polynomial, or you can say quadratic expression. Clear? So let us talk about the general form of quadratic equations or quadratic polynomial. Okay, so the general form is actually ax squared plus bx plus c. What is this? This is a quadratic expression. Now here is a condition. Before telling that condition, visualize this. Okay, if I remove the part ax square from here, I can do it. Then what will be left? Bx plus c. Is that a quadratic? No, this is not a quadratic. This is a linear equation. Or not an equation, this is a linear expression. Okay. So you saw that if we remove the part ax square, or you can say if the part ax square becomes 0, then that will not be longer a quadratic expression. Okay. That will be a linear expression. Okay. So, first condition for this quantity or for this expression being a quadratic expression is a must be not equal to 0. Clear? A must be not equal to 0. Because if a equal to 0, if we put any value of x here, what will happen? If we put any value of x here, 0 into anything is equal to 0, so x square will be equal to 0. So that will be a linear expression. Okay, B and C can be equal to 0. B and C can be equal to 0 because if there is x square only in an equation, that will, or expression, that will be a quadratic expression in equation. But A cannot be equal to 0. ABC here can be real. This can be complex, can be negative, can be positive, but A will not be equal to 0. Okay. So now let us talk about roots. So let us take fx equal to ax squared plus bx plus c. What is this? This is a quadratic polynomial, right? Now you can see that the highest power here is 2. So there will be two roots. Okay, alpha and beta. Now you can say that alpha and beta are the zeros of fx, or If there is an equation like ax square plus bx plus c equal to 0, you can say alpha and beta are the roots of that equation. Okay, or the solutions of that equation. Now, listen, here it will interesting and important discussion. Alpha and beta are the roots of fx. That means alpha and beta are those values of x for which fx will be equal to 0. Okay, you know the definition of roots or zeros. Alpha and beta are those values of x for which fx will be equal to what? 0. So, if alpha will be equal to 0, and also we can say if beta is equal to 0. This is an important topic. You may feel this is easy, but there are many questions on this topic also. So remember, if alpha and beta are the zeros of fx equal to x square plus bx plus c, then we can say f alpha is equal to 0 and f beta is equal to 0. Clear? So these were the fundamentals of quadratic equations. Now let's go for the next topic, which is solution of quadratic equation. Okay, now we are going to study about the processes of finding solutions of a quadratic equation. Okay, so let us make a chart. So here it will be quadratic equation solving process. There are basically three processes of solving a quadratic equation. First process is factorization. Okay, factorization. Second process is what? Completing the square. Completing the square. And the third process is quadratic formula. Quadratic formula. We will discuss factorization method and completing the square method quickly, and then we will go to the quadratic formula. Okay, so you know factorization method. You are learning it from actually class 6, 7, 8. Okay, but still, let us take an example. Okay, I don't think so. There is something here hard. Okay, there is nothing hard here. Just you to factorize. Let us take an expression x square plus 4x plus 3 equal to 0. Okay, so this can be written as x square plus 3x plus x plus 3 equal to 0, right? So x into x plus 3 plus 1 into x plus 3 equal to 0. So this will be x plus 3 into x plus 1 equal to 0. Now the product of these two quantities is equal to 0. So one of these quantities must be equal to 0, or both can be equal to 0. So what we can say, x plus 3 is equal to 0, or x is equal to minus 3. And from here we can say x plus 1 is equal to 0, or x is equal to minus 1. From here we can easily get the roots, right? Minus 3 and minus 1. No problem. This method is the simplest method, okay? And we generally use this method to solve easy quadratic equation, okay? Which are factorable, okay? Which are factorable easily. So this is factorization method. I don't think so. I need another example for this. Okay, you know this. Now we are going to completing the square method. So we are taking this equation again, x square plus 4x plus 3 equal to 0. Now what we will do? what is the main motive of this completing the square method? We need to make a whole square. Okay. Then after that, something will come in the form of a square minus b square. Okay, then we will apply a plus b into a minus b formula. Then again factorization. Then we will set it equal to 0 to get our answer. So let's do it for this question. So this will be x square plus what we can write 2 into x is here actually 2 into x into we need to get 4x. So we will write 2 here again, right? Plus 2 square, right? 2 square. Now we added a term 2 square, so we need to subtract that term also. So this will be minus 2 square here plus 3 equal to 0, right? Very easy. So this part will be equal to x plus 2 whole square. And here, the 2 square is equal to 4. So minus 4 plus 3 is equal to minus 1 equal to 0. So this will be 1 square. You can write. So we can apply a square minus b square formula. So this will be x plus 2 plus 1 into x plus 2 minus 1 equal to 0, right? So from here, we are getting x plus 3 actually into x plus 1 equal to 0. You can see we're getting the same. So from here, we can say x equal to minus 3. And from here, we can say x equal to minus 1. So this is the completing the square method. Okay. So this method is less used. Okay. At first, we need to try to factorize a quadratic expression or equation, you can say. If that does not work, then we will go with the process quadratic formula, which we are going to discuss now. Okay, first always try factorization to solve a quadratic expression. Okay, then we will go. If that does not work, then we will go to quadratic formula. We will not use this. We will not use this. Okay, so let us discuss about quadratic formula. Okay, I am going to next page. So many of you know that I'm writing it here. Many of you know that if there is some equation like ax square plus bx plus c equal to 0, where a is not equal to 0, obviously. So what we can say? We can say that x equal to minus b plus minus root over b square minus 4ac by 2a. Many of you know this. This is also called Sridharacharya formula. Okay, many of you know this. But how this comes? Okay, how this thing comes? What is the proof? Let us discuss this before. Okay, so our equation was ax squared plus bx plus c equal to 0. We can prove this by using completing the square method. Okay, so first what we will do, we will divide both sides by a. So this will be x square plus b by a into x plus c by a equal to 0. Okay, now what we can say, this will be x square plus 2 into x is already here, 2 into x into, we need to make b by a into x. So we need to multiply b by 2a. Okay, you can see 2 will be cancelled out and b by a into x will be left here. Plus, we will get b by 2a whole square. Well, now we added a term, so we need to subtract that term. Also, this will be minus b by 2a whole square, right? Plus c by a equal to 0. Simple. So now this part will become x plus b by 2a whole square, right? And here, this part is b square upon 4a square plus c by a. If we take this common, so this sign will be minus a. Okay, this will be equal to 0. So now we can write this x plus b by 2a whole square minus, this can be written as, if we take LCM, 4a square, and here it will be b square minus 4ac. Simple. Okay. So now what we will do? You can apply a square minus b square formula. Okay. But I am not applying it. This is for proof purpose. So we can write x plus b by 2a whole square equal to this b square minus 4ac upon 4a square. Now, if we want to, if we root both sides, so this will be x plus b by 2a here equal to plus minus b square minus 4ac whole root divided by root of 4a square is equal to 2a, right? So from here you can say that x is equal to minus b by 2a plus minus whole root of b square minus 4ac upon 2a. So we can write this as minus b plus minus root over b square minus 4ac upon 2a. So yeah, we proved it that if ax square plus bx plus c is equal to 0, then x is equal to this. Okay, this is known as quadratic formula or Sridhar formula. This is very important. This is very important. And from here, we derive the concept of discriminant, which we will discuss after this, which is our last topic of this lecture. Okay, so you now you understood how this comes. Okay, now let us apply this formula for some questions, right? Let us take equation x square, like x square plus 2x minus 3 equal to 0. So we will apply that formula. So this will be x equal to, now in this equation, a is equal to 1, b is equal to 2, and c is equal to minus 3. Let us apply the formula. So minus b minus 2 plus minus root over b square, which is 2 square, which is equal to 4, minus 4 into ac, 4 into 1 into minus 3, right? Divided by divided by 2 into 1, 2a. Okay, right. So this will be minus 2 plus minus root over 4 plus 12 divided by 2. 4 plus 12 is equal to 16. So this will be minus 2 plus minus root 16 is equal to 4 by 2a, right? So from here we can say two roots are there. First is minus 2 plus 4 divided by 2, so which is equal to 1. Okay. And the another root is minus 2 minus 4 divided by 2, so minus 6 by 2, which is equal to minus 2. These are the two roots of the equation. Okay, so let us apply for this equation x squared plus x plus 1 equal to 0. This is a famous equation. Let us solve, then I will tell you why. Okay, so from here we can write x equal to, now in this equation a is equal to 1, b is equal to 1, c is equal to 1 also, right? So x can be written as minus b minus 1 plus minus root over b square 1 minus 4 into ac, 1 into 1 divided by 2a, 2 into 1, right? So this will be minus 1 plus minus root over minus 3 divided by 2. Now there is negative under the root, right? There is negative under the root. So the roots of this equation will be what? Will be complex, right? So this is minus 1 plus minus root 3 iota divided by 2. Okay, you know iota, maybe. Iota is equal to root over minus 1. Okay, when you will read complex number, you will see it. Okay, so these roots can be actually written as omega and omega square. Okay, this is the topic of complex numbers. Okay, so yeah, I hope you understood the use of this formula. What is the actual use? What is actually the use? You can see that we got complex roots of this equation, and which is not easy to derive using factorization. Okay. So we use this formula and we also got these solutions, complex solutions. So I hope now you can easily know that why this is very important formula. Okay. So now let's go to the next topic, which is discriminant or nature of roots. Now we are going to study about the discriminant. Okay. And then in this topic, we will continue nature of roots. Okay. So let's start. What we have learned that in that is the equation like ax squared plus bx plus c equal to 0, we can say that x equal to minus b plus minus root over b square minus 4ac by 2a. Now, see here. See this b square minus 4ac. This part is called discriminant. What discriminant? And this is denoted by capital D. Okay. So you can say that x is equal to minus b plus minus root d by 2a. This is also correct. Okay. Now, how the discriminant decides the nature of the roots? Let's discuss. If if d is greater than or equal to 0, if d is greater than or equal to 0, you can see that b square minus 4ac is under the root, right? B square minus 4ac is under the root. So if b square minus 4ac is greater than equal to 0, then the roots will be real because there is positive number or 0 under the root. So that will be real, right? I am not talking about rational or irrational. I am not talking about that. I am only saying that if b square minus 4ac is greater than equal to 0, so this will be real, the roots will be real because root over b square minus 4ac will be real, right? So the roots will be real. So we can say if this is greater than equal to 0, then roots will be real. Okay. Now if d is equal to 0, that is a condition of real roots also, but now I am taking d is strictly equal to 0. If b square minus 4ac is equal to 0, this whole part of root will be cancelled out, and what will be left? Minus b by 2a will be left. So our answer will be x equal to minus b by 2a only, right? Because the whole part root b square minus 4ac will be vanished, right? Root 0 is equal to 0, so that will be vanished. So how many solutions are we getting? We are still getting two solutions, but the solutions are equal to each other. Okay, the solutions are equal to each other. So we can say that roots will be equal. Roots will be equal. Okay. If d is equal to 0, roots will be equal. Let's take an example. If there is equation x square plus 2x plus 1 equal to 0. Okay. So if we find the discriminant of this equation, d will be equal to b square is 2 square 4 minus 4 into ac. So 4 into 1 into 1, which is 4 equal to 0. So discriminant is equal to 0. So the roots will be minus b minus 2 plus minus root d. This is 0 by 2. Now this part will be vanished and what will be left? Minus 1 will be left. So the two roots of this equation is minus 1 and minus 1. That means that those are equal. Okay. So here, if d is equal to 0, then roots will be equal to each other. Now, if d is less than 0, then what will be the condition? If d is less than 0, then you can see that under the root there will be a negative number, and that does not exist in the real world. That will be complex number. Okay, so that so that the roots of that equation will be complex. If d is less than 0, you can easily see the logic. I have taken that example before. You can see here. Here, discriminant is minus 3. So, root over minus 3. So, this will be a complex number. Okay, root 1 minus 1 plus minus root 3 iota by 2. This will be a complex number. Okay. So, if d less than 0, roots will be complex. Okay. Now, if d if d is a perfect square, what? Perfect square. Okay. Then the roots will be what? The roots will be rational number, right? The roots will be rational number. Why? Because if d is a perfect square, then a root of a perfect square will be that the square will be removed, right? So we will easily get a number. We will easily get a number which is rational only if a, b, and c also belongs to what? Rational number. For then we will get rational roots. Clear? Now let's go for the next thing. Okay. Now there are some points. I am writing it here x equal to minus b plus minus root d by 2a. Now in the equation ax square plus bx plus c equal to 0. Let us take a, b, c are rational numbers. Okay. But d is d is not perfect square. Listen carefully. D is not what? Perfect square. Then, if this is the condition, then what we can say? We can say that the roots will be irrational firstly. Okay, the roots will be irrational. And if the roots are irrational, those roots will be conjugate of each other. You can see here, first root will be minus b by 2a plus root d by 2a. And the second root will be minus b by 2a minus root d by 2a. You can easily see that these two roots are conjugate of each other. Okay, so what we can write? The roots will be irrational and will be conjugate of each other. Okay, if these conditions are true, then we can say this. Clear? You can see easily, you can see the proof. I am not talking anything without proof. Okay, you can easily see the proof. That first is plus root d by 2 and the next is minus root d by 2. So these two roots will be conjugate of each other, right? Same thing we can say for complex roots. Like if there is ax square plus bx plus c equal to 0, where a, b, c are real, okay, and d is obviously less than 0, then the roots will be what? D is less than 0, the roots will be complex, right? And and the complex roots in will be conjugate of each other. That means if one complex root is p plus I cube, the second complex root will be p minus I cube always, right? Okay, I can easily take an example. Let's take x square. Let's take that example again. X square plus x plus 1 equal to 0. We are taking that example again. Okay. What we got? X equal to minus 1 plus minus root 3 into y divided by 2. Okay. So here, if you notice, we are getting actually two roots, minus 1 by 2 plus root 3 by 2. This is first root. And the second root is minus 1 by 2 minus root 3 by 2 into I. Right? So you can see that these two roots are conjugate of each other. Okay. So what we can say? The roots will be rational. Sorry, the roots will be complex. Okay, the roots will be complex and will be conjugate conjugate of each other. Remember these 2 points. Okay, that means if one root is p plus iq, okay, then the another root will be p minus iq. Remember this. So these are the basics of nature of roots. We will discuss other things also after some lectures. Okay, we will also discuss that other things after learning the graph. Okay, those are defined. But yeah, now we will move for the questions on these topics. Now we will start question solving. Okay, so first question is this. So we will solve some questions now, but before I solve every question, you should try each question one time by pausing the video. Okay, so our first question is this one. So let's start solving it. Okay, so what is given? We need to solve this equation. A by ax minus 1 plus b by bx minus 1 equal to a plus b. First, what we will do, we will bring this b in the left hand side. Okay, so this will be a by ax minus 1. We will take this b with this term, so it will be minus b plus b by bx minus 1. We will bring this term a in the left hand side, so this will be minus a here equal to 0. Okay, now here this will be a minus abx plus b divided by ax minus 1 plus this will be v minus abx plus a divided by bx minus 1 equal to 0. Now from these two terms you can take a minus abx plus b equal common, right? And in the bracket here it will be 1 by x minus 1 plus 1 by bx minus 1 equal to 0. So from here, what we will get? We will get a solution. We will get a plus b equal to abx, right? Because if we put this term equal to 0, a minus abx plus b equal to 0, we will get a plus b equal to abx. So from here, we will get x equal to a plus b upon ab. We got a solution. Now from here, if we put this term equal to 0, what we can say? 1 by ax minus 1 will be equal to, if we move this term in the left hand side, okay, this will be minus 1 by bx minus 1 simply. So now we can write this as ax minus 1 equal to minus bx plus 1, right? So it will be a plus b into x equal to 2. So from here we can get x equal to 2 by a plus b. This is also a solution. So we got two solutions, x equal to a plus b by ab and 2 by a plus b. Okay. So yeah, our first question is solved. Now we will go for the second question. Our second question is this. This is an interesting question. So you should try this question one time. Okay. So first what you will do, let x minus 1 is equal to a. Okay. So what we can say, x minus 2 will be equal to a minus 1. So our equation will be a into a minus 1 equal to, now 15 upon 14 square. 15 can be written as 14 plus 1 divided by here it will be 14 square. So now if we break this fraction, this will be 14 upon 14 square. This is 1 by 14 plus 1 by 14 square. Right? Now we will open the bracket. So this will be a square minus a. If we bring these two terms in the left hand side, it will be minus 1 by 14 minus 1 by 14 square. This is equal to 0. Now from these two terms, you can see a square minus b square form. So this will be a plus b into a minus b. So a plus 1 by 14 into a minus 1 by 14, a plus b into a minus b. And from these two terms, if we take minus common, so in the bracket here it will be a plus 1 by 14, right? This is equal to 0. Now we will take a plus 1 by 14 common. Okay, so in the bracket here it will be a minus 1 by 14 minus 1, which is equal to 0. Now from here, what we can say, a is equal to minus 1 by 14. So if we put a equal to x minus 1, this will be x minus 1 equal to minus 1 by 14. So x will be equal to 1 minus 1 by 14. So our first solution is 13 by 14. We got our first solution of x. The second solution we will get from here. From here we can say a will be equal to 1 by 14 plus 1, or you can say 15 by 14, right? Now a is equal to x minus 1. So x minus 1 will be equal to 15 by 14. So x will be equal to 15 by 14 plus 1, which is equal to, you can say, 29 by 14. So we got two solutions. X equal to what? X equal to um, 13 by 14. And the second solution is 29 by 14. Okay, clear? I hope this is clear to you. So now let's go for another. Now here is a concept. What is saying, if ax square plus bx plus c equal to 0 and a plus b plus c equal to 0, then we need to find the roots of the equation. Okay, so how we will do it? First see here. We will start from here. Okay. So what is saying, a plus b plus c is equal to 0. From here we can say b equal to minus a minus c. If we take minus n common here, it will be minus a into a plus c. Okay, in the bracket. So now we know that if there is equation like ax squared plus bx plus c equal to 0, x will be equal to minus b plus minus root over b square minus 4ac by 2a, right? Now we will put the value of b here. So this will be, if we put here, this minus and this minus will be plus. So this will be a plus c plus minus root over. Now minus a plus c whole square, that will be a plus c whole square. Here minus 4ac. Okay, divided by 2a. Now what we can say, a plus c plus minus. Now a plus c whole square minus 4ac, this is the formula of a minus c whole square divided by 2a. Okay, now this will be a plus c plus minus, uh, here a minus c, root a minus c whole square, we can say it a minus c, right, divided by 2a. From here we will get two solutions. First is a plus c plus a minus c divided by 2a. Now here c and c will be cancelled out, and what will be left, 2a upon 2a, which is equal to 1. And from either, and we will get the second solution, a plus c minus a plus c divided by 2a. A and a will be cancelled out. What will be left? 2c by 2a, which is equal to c by a. Okay. So yeah, we got two solutions of x. X is equal to 1 and c by a. Now this is a concept because you should remember this directly. Okay. What you need to remember? So see this proof carefully first. Okay. I'm giving you time. See this proof one time. Done. Now you need to remember this. What you need to remember? If the sum of the coefficients of x squared, x and 1, okay, that means ax squared plus bx plus c equal to 0. So the sum of a, b and c, okay, of a quadratic equation is equal to 0. Then two roots of that equation will be x equal to 1 and the another root will be coefficient of 1 divided by coefficient of x squared. That means x equal to 1 and another is c by a. You will remember this directly. Note this carefully. Okay, note this. This is very useful. Note this thing. Clear? Now let's go for the next question where we will use this concept. Okay, so our question is this. So now what is saying, if the roots of the equation this are real and equal, then prove that b is equal to a plus c by 2. Now, anyone will, if you apply b square minus 4ac equal to 0 formula, right? Discriminant equal to 0. You can solve this like that way also. But see here carefully. The coefficients are b minus c, c minus a, and a minus b. If we sum this all, b minus c plus c minus a plus a minus b is equal to 0 because these are cyclic coefficients, right? So, if this is equal to 0, what we learned? We learned that the x will be equal to 1 and this. So, we will get the roots of the equation x is equal to 1 and coefficient of 1 which is a minus b and coefficient of x square which is b minus c, right? Now what it is telling that these are equal, so we will put 1 equal to a minus b upon b minus c, right? So a minus b will be equal to b minus c, or we will get 2b equal to a plus c, so b will be equal to a plus c by 2. This will complete the proof here. Okay. And if you go through that process, the alternative one, that will be a lengthy process, very lengthy process. Okay. So use this technique and that will be very useful. So yeah, there are no more questions. So if you watched this lecture till this, thank you. Okay. And make sure if you have any doubt, make sure to comment. I will reply as soon as possible. So thank you for watching. Okay, thank you for watching. Our next lecture will come soon. Okay, and we will also upload normal question solving videos as before. But besides that, we will continue the quadratic equation lecture series. Okay, so thank you. I am ending this lecture today.